Alright, so we're live. So we're going to talk about exponential growth. Basically, up until this point, we've been working with exponents, right? And exponent rules. Rico, I'm talking. We've been talking about exponent rules, right? You know, same bases when you multiply, the same bases with exponents and you multiply them, you add the exponents. Same bases and you divide them, you subtract them. You know, things like that, all those kind of things. With an exponential equation, an exponential function, you're going to have something like this. Y is equal to 2 to the x. What is different about this than any other equation I've shown you so far?
Because we don't know what the exponent is.
Right. The exponent is the x, right? The x is the exponent. I've never done that to you. I've always had the x was just a base, right? And it might have had an exponent to it. But I never had the exponent be the x. Does that make sense? So the unknown is the exponent, right? And when you see something like this where the unknown is the exponent, that represents exponential growth or potentially exponential decay, okay? So that's what we're going to be talking about. And when you have exponential growth, I'm just going to show you what that looks like, right?
Yeah.
Exponential growth could start like this, and it goes like this for a long time, and all of a sudden it starts to go up. It starts to go really fast up eventually.
Oh,
What?
it goes down.
Exponential growth is why so many people in this country right now are wealthy.
So
Right?
exponential decay
Their
means
money
decay.
actually did this for them, right?
How does this work?
So what are you guys talking about? Just give me an idea. All right, so this isn't going to work for me. Rico, this is not going to work for me, right? I'm talking, right? You guys are listening to me right now. Is that clear? Lisa? Okay. All right, this is exponential growth. This is the most powerful thing. Einstein says exponential growth and compound interest is the most powerful thing in the universe, right? Einstein said that, and he's right. Exponential growth is phenomenal. You can start out with very little amounts of money and add to it each month. And over a long period of time, eventually it starts to rapidly grow, right? Here, you might be making like a half a cent per month.
What?
Here, a half a cent per
That's
month.
below minimum
You just
wage.
always make a cent no matter what. Where is that coming from?
Like if you're investing in something and you're getting a percentage.
Like if you had stocks.
You're getting,
and like
exactly, if you had
apples.
stocks or something, right, for example, and you're getting a certain amount, but you keep investing more money, you keep taking that money that is coming in from your interest, and you're reinvesting it so that it continues to grow, compounds,
Like my dad had stocks in Apple, and they had grown to a certain point. So what he did is he cashed them out and used them to pay off like credit card debt. And
Sure,
stuff like that.
sure. But like if all of you could easily be millionaires by the time you're 60 or 70, because you have the benefit of all this time,
Yeah.
right? I would not be able to do that because I don't have that benefit. You know, in 20 years, I might not be looking quite as amazing as I look now, right? But in 20 years, you guys are going to be still young, right?
Yeah.
So, and you're going to have another 30, 40, 50 years, right? So if you can have money in something and it's earning money through interest, right? You guys know what interest is?
Yeah.
Right?
Yeah.
So you've got your original amount that you earned. That you invested. And then each month you're earning interest because the bank is paying you to have it in their bank. Or the company that you invested it in, Apple, is paying you to let them use that money. Does that make sense?
Yeah.
They're paying you as interest, right? And if that interest keep reinvested into the company, into that thing, then it's growing in value. So suddenly your initial amount is a little bit more. And then it's a little bit more. Then it's a little bit more. Guys, this is really important. Trust me, it's really important. This is how you could actually become wealthy. Very few people act on this. I'm going to tell you right now. Very few people act on this. But I'm telling you right now, what you could do is you could become a millionaire. Probably by the time you're 60 years old, if you very easily, very easily, if you follow this advice. If you do that, if you're conscious on what you're doing.
Wait, so how do you do that? Investing in stocks?
Yes, you can invest in stock. Well, we can. Yeah, I'm not going to talk about becoming a millionaire today, but
That's exactly what you were just talking about.
but this is an example. Who was it?
What?
What?
Why are you doing that? I am teaching a lesson, right? Can you please throw that away? Thank you. See me after class, okay? Okay, thank you. You guys. I don't even know where I was at, right? So, exponential growth. It looks like it's not growing much for a very long time, and then all of a sudden, as the principal, the amount that you actually own, gets bigger and bigger, it starts to make way more. You're making half a cent. Every month you might be making $10. And then a few years later,
That's
every
still
month you
below
might be
minimum
making
wage.
$100. And then a few years later, you might be making $1,000. And a few months later, a few years later, you might be making $10,000 a month, just by your money being invested, right? And eventually, you could be making $1 million a month. It grows exponentially.
Well,
Gary.
actually,
Right?
but $10 a month is actually, it's below minimum wage
Yeah.
here, but in like most states, like minimum wage can be like $5, and here it's
That's
like 11.
Yeah, but half
Yeah,
a
but
cent
that's
is also
per
below
hour.
minimum
That's
wage.
per hour. We're not talking per month.
Oh.
That's per hour. Yeah, that's wage per hour.
Oh
But
my
anyway,
God, that's way below.
so exponential growth is an amazingly powerful thing. Now, what does exponential decay look like? Exponential decay looks like just the opposite.
It's like a yin and yang.
It looks like this. It decays quickly and then slowly. Radioactivity is an example of exponential decay. If something has radioactivity, it starts to lose its radioactivity, but over time, it's very hard for it to lose all of its radioactivity. You know what I mean? It takes a very long time.
Well, yeah, like
Right.
uranium eventually
Right.
decaying into lead.
Right, exactly. It's going to take forever. So that's an example of an exponential decay function. This is an example of an exponential growth function. Now, what we're going to do today is we're going to talk about, did you guys read any parts of any chapter where they talked about this, how to graph this? I think
Yes,
I'm gonna
there is a
I think
part.
I will do that another day, because I don't want to waste the time right now, because I just want to talk about these two functions, these two equations, okay? And the t is the unknown sometimes, right? And if I gave you, let's just talk
The
about this.
first one's exponential growth, the second's exponential decay, right?
Exactly. This is
What's your
exponential growth. And let's just talk about the terms first of all. A is equal to the initial amount. All right? So if I was investing some money in a company, in Apple, right? I might then, that would be my A. That's my initial principal, my initial amount of money. Okay? Or if it was a rat population, it's my initial rat population, or the initial amount of rats I have in a population that's growing exponentially. Does it make sense? It could be anything. Yes.
And is T the rate at which it goes up?
R is the rate.
Okay.
T is the time.
Oh, the time, like
Okay.
if it was 10 years, then eventually
Right.
it would.
Exactly.
Is the time where you get to the point you want to be, or the time where it starts sloping?
Time is dependent on what you want to find. Where would it be at in 10 years? put a 10 there. If you want to know where it is going to be in 20 years, you put a 20 there,
Alright.
right? But usually the A is a very concrete amount. It's the initial amount you invested. And usually the 1 is 1, right? That stays. But the R is the rate, like 8% increase per year. You're earning 8% interest on something. Or the rat population is growing at, 25%.
That's the alarming rate.
Right? Yes, right. Whatever. Exactly. But the T is the big thing that can fluctuate, right? Everything else, guys, everything else is going to be constant. Does that make sense? Right? In these? All right. So A is your initial amount. 1 is 1, right? R is your rate of growth, right? Rate of growth or your rate of decay or rate of decay. Okay? And T is your time. Usually time is in years, okay? But it wouldn't necessarily have to be. Because, you might want to know about rat populations, growing,
Per month.
Daily.
this keeps, try not to hit this, my dear. You can,
Yeah.
with your foot.
I can't see.
So, right, I mean, you might want to know in terms of rat population, per month or something, I don't know, we'll see. But, so that's what those stand for. So now let's take an example. I'm just going to make one up, but I'm going to use wording for this. Here's our first example. The original value of a painting. Original value, so write this down as I do it, of a painting is $8,500. In Santa Fe, that's cheap, right?
Yeah.
If you go into the galleries in Santa Fe, right, some of them are like $25,000, $52,000. They might take 400 years to sell at that price, but they still are that price, right?
400.
Right. Okay. Okay. Comma, and the value of that painting increases by 2% per year. And it says write an exponential growth function. Function is just basically an equation. Maybe to model this. They love these words, so I'll just stick to it. To model this, comma, not comma, period. Then find the value of the painting after 20 years. Okay?
It's a lot of words.
That's a lot of words. I'll give you a second to finish it. Finish writing it down.
So,
Here, can you go to the blind
Or
one? Like, the car is really
if it
in my eyes.
rises by 2%,
This one?
Yeah, it's all up in my eyes.
so
Thank you.
that would mean, so here, let's use this equation. So y
Okay.
equals
Are you guys ready?
No, then we can just plug it in, right? Yeah.
So you're going to plug it in. Notice, look at this for 1 second. If you have an original amount, let's say $8,500, right?
Right.
And if it's 1 plus r, let's think about what that means is.
Like 2%?
It's the original amount times itself, and times 1 is itself, right?
Yeah.
Plus the original amount times the rate. Does that make sense? So that gives you the amount that you own, you actually own after.
What's 2%? What 2%? You have to convert that into the decimal.
You have to convert the percentage. Yeah, the rate is usually in a percent. It's usually in a percent, but you've got to convert it to a decimal, right? So
2%.
here we go. We know this is going to be, this is growth, exponential growth, because it says it increases, right? So we're going to use this. So y is equal to the initial amount, 8,500, parenthesis. Now 1 plus, we'll do that, 1 plus 0.02. Am I right?
Yes.
Right?
Because it's
And then I'm going to put t right now. Right?
So for the years, you're going to turn it into a decimal by 2
for the
points.
percent.
Yeah, to
'Cause-
turn
Think about it,
percentage.
because
2%.
percentages is out of 100, right?
2%.
So if it were
is-
2%, it'd be
it's gonna be
0.2 or 0.02.
0.02. You got to move the decimal to the
20%,
left.
and then 20% would be 0.2.
Right?
And then the 1 is coming from where?
Just
The
the
formula.
initial
Just
equation.
And then 1.
Yeah, just
Plus r. So 1 plus 0.02.
And is the t undefined, or do we need to
The
replace
t
that?
stays as a t for now. Okay? For now. Okay? Can you see okay? No, I can't see. Sorry. Okay? So now what is 1 plus 0.02?
1.0.
Right? It's 1.02. Right? 1.02. So I could rewrite that as y is equal to 8,500 times 1.02. That is now the first part of the question. It says write an exponential growth function to model this. There we go. That's my exponential growth function. Now, notice I left the exponent as a variable, as a t, right? That's because I don't know for sure. I might want to use this to find out how much the painting is going to be worth in 100 years, right?
So, Gary,
I might want to know how much it's going to be worth in 1,000 years or in 10 years. So, but then the second part of the question says, then find the value of the painting after 20 years. So what does that mean I'm making t now? 20, right? And so,
Then do we just multiply 8,500 by 1.02?
well, yeah, you'll see in a second. 1.02 to the 20. That's what they're asking me now to figure out. Now, it's very, without a calculator, it is really a bummer to do this.
20.02,
Right.
solve that.
This would be really a bummer because what this means is 1.02 times 1.02 times 1.02 times 1.02 times 1.02. You got the idea, right?
wait, can you show us how to do exponents on a calculator?
Yes. So on a calculator, you're going to want to use a calculator for this. And I have these little, I'll just use this one. Like these kind of calculators here, right?
Yes.
That I have. They've started going missing, some of them, so make sure I get them back.
Don't steal them.
But there is a key that says this on the calculator. There is a key that says this: y to the x power. Right?
Yes.
There is a key on the calculator that says y to the x power. Okay? And the way you do that, the way you do it on a calculator, if I wanted to do 9 squared, right? What I would do is I would press 9
and then x.
and then I would press this weird button. So, and then I would press y to the x, and then I would press 2. And that would give me 9 squared, which is 81.
Yay.
Right?
Yeah.
Right? Does that make sense? So, and so using this method, using that with the calculator, it's really easy. All I have to do is go 8,500, right? 8,500 times, and now I'm going to write 1.02, this button, and then 20. Does that make sense?
Yep.
1.02, 1.02, where's that button? There it is, and then 20. and then I hit equals, and it gives me
Some random number.
y is equal to 12,630 dollars approximately.
Wow.
Oh my
Approximately.
gosh.
So in
Wait,
20 years,
Is that
20 years.
does
Is that
mean-
multiplied
Yeah,
times?
did you multiply the 8,500? Because you
Times
said
8,500.
yeah, because you
all right,
just said
so
he did
so
why.
I did 8,500 times,
Okay.
and then
Okay.
this, that button, and
And
then
that came out to be.
But if you're concerned about that, you can always do it in reverse. You could do this raised to the 20 and then times 8,500, right? I'll do that just to be safe, just to make sure. Because I have not ever used this calculator for this before. So, you know, every calculator is a little weird. So you got it 1.02, press that weird button, and then 20, and that equals 1.48 times 8,500 equals 12,630. Okay, does that make sense? See how that works? It's really pretty easy. Now notice, this figure right here in the parentheses, is it going to be more than 1 or less than 1?
More than one.
It's always going to be more than 1.
And that one's
So
gonna always be.
when it's more than 1, it's always exponential growth. It's getting bigger. Because you're always multiplying it by something more than 1, so it's always going to get bigger. Is exponential decay going to be more than 1 or less than 1?
Less than
It's
one.
going to be less than 1.
The answer's in the
And
question.
so when it's less than 1,
Come on.
it's going to be getting smaller and smaller, right? As you, like for example, an example of less than 1 would be 1/2. Am I right?
Yeah.
Right, guys? So 1/2. An example of less than 1 would be 1/2. Let's do 1/2 to the 4th power. What would that be?
Will that be?
That's 1/2 times 1/2 times 1/2 times 1/2.
No, it's not 2, guys.
1/16. Am I right?
Yeah.
It's gonna be if you multiply a fraction times a fraction, it's going to be smaller.
you're right.
Right?
Yeah.
So a fraction times another fraction, it gradually gets smaller and smaller and smaller and smaller and smaller. Right?
Small, and it won't ever get to 0.
Yeah, if you're doing plus, but this is multiply. This is exponents, right? Okay, so it's fist to 5. Does that make sense?
Yes.
Yep,
All
that
right.
makes a lot
So
of
now,
sense.
let's say this is our another second problem. We're just going to change it slightly, right? Even though paintings don't usually decrease in value, although they might. But
Sometimes they'll go up.
let's just
If
say
the artist makes
let's
more
say
paintings.
it decreases in value, and we'll say by 10%. Why not?
Oh my God.
10%.
Just
Write an
right.
exponential growth function to model this, then find the value of the painting after, you know, let's say
50 years.
50 years.
What?
Welcome.
Okay?
It's gonna be like,
Okay, so now we need
It's
to
gonna be
do
like $2.
why.
Yeah, so what do we have to replace here?
Sold.
why?
What do we have? We've got 8,500, right? We're going to use this now. This is decay, right? Because the value is decreasing, it's exponential decay, right? So I'm going to use this formula, right? So we've got y is equal to 8,500, the initial amount, times 1 minus, how do I write 10%?
0.1.
10%, right? I got to move the decimal from here, Basie, to the left 2 places, 1, 2, so it's 0.1. That's 0.1, right? So 1 minus 0.1 to the t power. What is 1 minus 0.1? I'll put a 0.
9.9.
0.9, right? Am I right? 0.9? So y is equal to 8,500 parentheses 0.9 to the t. Yes?
Yeah. Yeah.
Right?
Oh.
So now this is less than 1. Am I right?
Yes.
So that will be definitely decay.
Yeah.
Wait.
I said 1 minus 0.1. So think about it.
Well, 1 is.
1.0
Negative?
and then
No,
1.0 minus
No,
0.1.
because it's not below
right?
0, it's just below
So I've got to, that becomes 0, I've got to make that a 10, That's gonna be 9, put my decimal, it's 9.
Yeah.
0.9, right?
Can I do the calculation?
So now, yeah, do the calculation. Let's have,
Can we have many people do this?
yeah, you can get one. So let's find out what it is. So now this is our function that they asked us to write. When t is 50, right? 0.9 to the 50th.
So it's gonna be. Turn it on.
Oh, crap.
No, that's not the right answer.
50th.
43.80708.926.
It's $43.9.
43.80708.926.
Yeah, we got the same answer. We either
Eight,
both did
seven.
it wrong or we both did it right.
Wow,
Ah.
that's
That is
kind of a
what
big decrease.
she hated.
Yeah.
Wait, it wouldn't be 43.87 because it's 43.807. So it'd just be 43.8.
I missed.
Geez,
Okay.
10% sounds like not
0.80.
that much, but once it's
Right.
Or
10%
0.8.
is a
Technically,
lot.
if you were to round it, it'd be 0.81.
Yeah.
That's fine.
After 20 years, it's $43?
Yeah, after 50 years.
Oh,
So
sold.
that's an example of exponential decay, right?
Just wait a while. You guys.
In 1 year, it wouldn't have been that much. In 2 years, it wouldn't have been that much. In 3 years, in 20 years, it would have been something, but not a huge amount. But by 50 years, it's a huge amount, right? That's the example of that's what exponential decay is. So anyways, that's the lecture for now. And then the homework is to practice this, and then on the back side, there's also just review on exponent rules.
This is our homework tonight.